Hello, this is Mr. Henry, and welcome to lesson 13.8. In this lesson, we'll be making and interpreting box and whisker plots. This intro question says, how do I interpret box and whisker plots? Down below in the Get the Goof, we have a stem and leaf problem from the last lesson. It says, make a stem and leaf plot of the following data. Describe in words the mistakes that were made. Okay, so let's see what mistakes were made. Well, just looking at it, I'm looking for common mistakes that I see. I don't see any off the top of my head just yet. Let's see. They have the stem of 0, the largest stem of 4. They have everything in between. So far, so good. Let's see. So let's check the numbers. They have, this would be 0, 0, okay, 0, 2, 0, 7, 1, 3, 1, 5, 1, 9, 1, 4. There's nothing in the 20s. 32, 43. Everything's okay so far. I can see one thing that's wrong and one thing that can be done better. The one thing that's wrong is there is no key. So 4/3 equals 43. That is a mistake, that there is no key there. The other thing I see that could be done better is you could put the numbers in order from least to greatest. So if you make your 0, 0, 2, 7, 1 of 3, 4, 5, 9, 2, 3, 4, 3, 2, 4, 3, and then your same key. This would be a much better stem and leaf plot, or I'd say it's better. I'm not saying it's a ton better, but I definitely like having the organized list instead of the disorganized list. We've got ourselves here a couple vocab words. First of them is box and whisker plot. A box and whisker plot organizes data values into 4 groups. I will say that each group represents 25% of the data. So when we break something up into our 4 groups, we're going to break it in half. Then each of those groups we're going to break in half again. So we're going to get 4 groups of data that each contain 25% of the data. Now we've got a couple other vocab words. First of them is a lower quartile. The lower quartile is the median of the lower half of the data. So for demonstration purposes, let's play pretend here. Let me erase this. Now, let's say we have our big list of numbers up here. Here's our list of numbers. Now, we're going to take our list of numbers and we're going to find the half, the median. Then we take this half, the lower half of data, and we're going to cut that in half. This number right here is the lower quartile. Then the upper quartile, we're going to take the upper half, cut in half. That's the upper quartile. And I want you to see what we have. We have 4 groups. 1, 2, 3, 4. Ignore all that stuff out there. We have 4 groups. Each group contains 25% of the data. Upper quartile, hopefully you know already, it's the median of the upper half. It's the middle of that upper half of the data. The other 2 vocab words here, one of them is the interquartile range. Interquartile range. What the interquartile range is, well, first off, do you remember a range is you take the big number minus the small number? Well, it's that, but for the quartiles. So in this case, you would take the upper quartile minus the lower quartile. So that number minus that number will give you the interquartile range, the difference of the upper quartile and lower quartile. And an outlier is a value that is widely outside of the rest of the data. This is another possible reason why sometimes data is skewed, where it doesn't quite look right, is if you have an outlier. One value who's maybe really far away from all the other values. It just doesn't seem to quite fit in. A simple little example I can think of would be, I don't know, if you're talking about rainfall or something like that, and you got like 3 inches and 5 inches and 4 inches and 8 inches, and all of a sudden there's this one day that it rains like 36 inches. Well, that would be an outlier because that value right there is nothing like the rest of the data. This guy is so different from the rest, so he would be considered an outlier. So let's get into making a Box-and-Whisker plot. Now, learning to make the Box-and-Whisker plot will help you understand it as well. So first off, it says here the lengths of songs on a CD are listed. Make a Box-and-Whisker plot of the song length. So I assume that is song lengths in seconds. So most of them are around 3 to 4 minutes is about right. Now, to make our Box-and-Whisker plot, we need 5 pieces of data. The first of them is the upper extreme, then the upper quartile, the median, the lower quartile, and the lower extreme. Now, the first thing we can do before we do that is we have to take our set of data and put it in order from least to greatest, because we can't find a median if they're all mixed up. So we're going to start by finding the order from least to greatest. So the smallest number is 173. The next looks like 179. Here's a 181 and 198. Those are all the ones that are in the 100s. All right. Now 200s. We've got a 206, 239, 246, 251, 257, and last two, 261 and 295. Alright, so we have our list of numbers in order from the least to the greatest. So let's start by finding the median, the middle. So I'm not going to actually cross off my numbers because I'm going to use them again. So smallest, biggest, small, big, small, big, small, big, small, big, one in the middle. That guy right there is my median, 239. So I got one number in the middle. So now think about it. I've taken my set of numbers and I've broken it in half. Here is half of the data, and here is half the data. This is the guy that's in the middle. I've broken him, this set of numbers, in half with the median. Now, each of these sides, I'm going to break in half again. So this side, since these numbers are smaller, this is the lower half of the data. So let's find the lower quartile. The lower quartile is the middle of that lower half. So where's halfway? Well, it's this guy. That is my lower quartile. See how there's two numbers smaller, two numbers bigger. That's half of the data. On the upper half, over here, well, the upper quartile would be this, 257, because that's halfway. I mean, if you cross off again or underline big, small, guy in the middle. So I broke all the data in half, then I broke the lower set in half, broke the upper set in half. The last two numbers, the extremes, are simply the biggest and the smallest numbers. So the upper extreme is 295. The lower extreme is 173. And now we're ready to make our Box-and-Whisker plot. These 5 pieces of information are the 5 pieces you need to make the Box-and-Whisker plot. In fact, that's the only 5 pieces of information we need. But we had to go through all that work of putting the numbers in order, finding the median, finding the upper quartile, the lower quartile, the upper extreme, by the way, upper extreme, lower extreme. By finding those 5 pieces of information, now we can make our box and whisker plot. So, first things first, we have a number line. We have to number it. We need a scale. Well, my scale should go from somewhere around 173 to around 195. Something like that. Well, let's just guess. Don't write this in pencil or something, so if you need to, you can erase. So I'm thinking like, what if I do like 170, 180, 190, 200, 210, 220, 230, 240, 250, 260, 270. Darn. That was close, but it wasn't quite good enough. So that was counting by tens. So I guess 20s? So I'm going to start a little bit lower, maybe like 130, 150, 170, 190, 210, 230, 250, 270, 290, 310, and 330. Not ideal. It would have been better if counted by tens worked. That would have been perfect, but it didn't quite fit. Now, I could do something funky like 15s would be fine, but I don't know. I didn't feel like counting by 15s, so I didn't. So the first thing you do is you plot these points not on the number line, but below it, or sometimes above it. So below the number line, 173, it'd be like right there someplace. Dot 181. 180 would be between here. That'd be 180. So 181 is just over a little bit more. 239 is about 240. 257, right around there. And 295, right about here. So we have our 5 dots representing our 5 pieces of information that we found. The upper extreme, the upper quartile, the median, the lower quartile, and the lower extreme. The last step is just make it look like a picture. Make it look like a box and whisker. So we're going to add whiskers on the outside, box on the inside, and don't leave them hanging. Boom. We've got ourselves a box and whisker plot. And that's all there is to it. So you take your set of numbers, you find the middle, the median, then you find the middle of the upper half and the lower half, those are the quartiles, and then finally upper extreme and the lower extreme. Now, I want you to understand that in this set right here, in this little piece, there's 25% of the data. And in this big piece, there's 25% of the data. So why is this guy really tiny and this guy really big? Well, the reason would be that although each section contains the same number of data points, these data points are closer together. These data points are more spaced out. But each contains, in this case, well, this has 2 pieces of data, 2 pieces, 2 pieces, 2 pieces. So this one is the 173 to 179. This is the, or I guess up to 181. This is from 181 to 239. From 239 to 257, which I guess is actually like 3 pieces of data. And this from 257 to 295. So each piece has the same number of data points. Each have 3. But the more spaced out they are, the bigger that section will be. The closer together they are, the more cramped it will be. Here we go. We're going to do letter B here. We're going to make another box and whisker plot. Just more practice. Practice never hurt. So first things first is we've got to take this set of numbers and put it in order from the least to greatest. So I'm seeing 14, 22, 27, 39, 45, 50, 56, 64, 80, and 84. Alright, so now we're in order from least to greatest. Let's find the middle. So small, big, small, big, small, big, small, big, 2 in the middle. With 2 in the middle, now we did this before. I remember we did this before. When we had 2 numbers in the middle and we're finding the median, you have to add them up and divide by 2. So 45 plus 50 is 95. And 95 divided by 2 is going to give us a 47.5. That would be right here. So this is my middle number. That's what's breaking this into this half and that half. Each side has the same number of points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's the middle. Now we're going to find our quartiles. So on each half, here, I have these 5 numbers. What's the middle of those 5? Well, 64. That is the upper quartile. Down here I've got 5 numbers. The middle one is 27. That's the lower quartile. That's the middle of the lower half. So we're breaking our group of numbers into 1, 2, 3, 4 pieces. And by the way, lower extreme is the smallest, upper extreme is the largest. So now we have our points that we need. We just need a scale and a graph. A good scale that would work here, I believe, is counting by tens. So let's see, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That'll work. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So our first point is at 14. And then at 27, 47 and a half, 64, and 84. Now these dots all appear to be fairly equally spaced. 14, 27, 47 and a half. This gap's a little bit bigger. 64, yeah, that's a little bit bigger. So this one right here seems the smallest of them. Whisker, whisker, and box. So we have our box and whisker plot. Alright, so I've done A and B, and here's letter C for you to try. Go ahead, pause the video right now, do this on your own. When you are ready to continue, hit play, and we'll go through it together. Alright, let's see how you've done. So putting the numbers in order from least to greatest, smallest, we've got 5 and 8 and 10. And then it looks like 14, 15, 24, 27, 37, 40, 40, and 47. And yes, you need both 40s. There's 2 of them here. You need 2 of them there. Alright, so I'm in order from least to greatest. The middle, let's check here. Big, small, big, small, big, small, big, small, big, small. 1 number in the middle. Now, that's the halfway point. It's cutting the rest of the numbers in half. So now let's find the upper quartile, the upper half. Well, what's the halfway point here? 40. That cuts my numbers in half. The lower quartile, 10. The upper extreme, the biggest number, is 47, and the lower extreme is 5. So now we need a scale from at least from 5 to 47. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 works perfectly. 15, 20, 25, 30, 35, 40. Ooh, it's supposed to be a 45. 45 and 50. Alright, dot. 5 and 10 and 24. That's not 24. That's 24. And 40 and 47. So we got our dots. Now you just make whisker here, whisker there, boom, 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 box in between. So making the box and whisker plot, not too bad. You find your median, you find the middle of the upper half, the middle of the lower half, and the two extremes. You then make a scale on your number line. You put dots below or above the number line, not on the number line. Below or above the number line. Connect the outside two with whiskers, and the middle three, get a box around them. So now, one problem for you to try from the textbook. This is page 887, number 1. Go ahead and make a box and whisker plot of that information. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see. We need to make a box and whisker plot. So we're going to start by putting our numbers in order from least to greatest. So 15, 20, 25, 30, 40, 55, 60, and 70. Okay, so I need my upper extreme, upper quartile, my median, lower quartile, and lower extreme. Upper median first, middle. 1, 2, 3, 4. So I'm going to find biggest, smallest, big, small, 2 in the middle. Well, here's a little hint. Halfway between 30 and 40, it's 35. That's going to be the median. If you take 30 plus 40, you get 70, and then 70 divided by 2 is 35. So median, 35. Right here, 35. So this is the halfway point of my data. Now, the upper quartile. Well, I've got 4 numbers, so big, small, big. I've got 2 in the middle again. So I've got to find out what's halfway between 55 and 60. Halfway between 55 and 60, well, 60 plus 55 is, 115. 115 divided by 2 is going to be 57.5. Lower quartile, same deal. I've got 4 numbers on this side, so I've got 2 in the middle. Halfway between 20 and 25 would be 22.5. And lastly, the extremes. Lower extreme is 15, upper extreme is 70. So now I have all the pieces of information that I need. I need to make a number line. I need to count from 15 to 70. So 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. 20, 40, 60, no. Oh, I counted by 5, so I'm doing tens. Too much. So that was 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 80. There we go. Okay. The lower extreme is 15 here, and then 22.5 is here, 35, 57.5, and 70. Whisker, whisker, box in between. So that is making a box and whisker plot. Hopefully you find the process not terribly hard. You basically find 3 medians and then you draw a picture. The rest of this is going to be interpreting a box and whisker plot. So here we have on the back of the note sheet, interpret this box and whisker plot. So we have a picture, we have a number line, numbers, 2 box and whisker plots already made for us, talking about company A and company B. The following graph represents the gas mileage of 2 different companies of cars. So I assume that's cars and they have different gas mileages depending on the type of car and blah, 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 blah. Well, let's check here. Oopsie, that's what I wanted. It says here, which company of cars has the least fuel-efficient car? So if this represents the gas mileage, miles per gallon, which car has the least fuel-efficient car? Which one is the least fuel-efficient? Which one gets the worst miles per gallon? And the answer is company B. That guy right there is the least fuel-efficient. And it looks like, it says, what is that car's miles per gallon? Well, first off, company B. And it looks like the miles per gallon is around, I don't know, what's that, 17 or so? So that is the worst miles per gallon, the worst fuel-efficient car right there, company B. Letter B asks, what is company A's average miles per gallon? And then what is company B's average miles per gallon? Well, the average. Remember, an average is always represented by the middle. Well, would we say the middle of this to be like in here? Does that make sense? Hopefully not. Now, yes, it's the middle of our picture, but remember what we said. Each section, there's 4 sections here. 1, 2, 3, 4. Each section represents the same number of data points. The reason why some sections are bigger is just in that area, those numbers are more stretched out. So in this area here, these numbers are really stretched out. In this area, the numbers are really close together, but they contain the same number of data points. Okay, so the middle of company A would be the median. This guy right here. This is the median of company A, which is about 36. So company B, the median would be right here, and that's about, I don't know, what do you say, call it 32, 32.5 or something miles per gallon. I've got 2 for you. First one here, letter C, says, which company has the most fuel-efficient car, and what is that car's miles per gallon? Go ahead, pause the video, take a couple seconds, shouldn't take more than that, and do this problem right now. Okay, hopefully you found that company B has the most fuel-efficient car because it has the highest upper extreme. And that looks like what? 45.5 mpg and company B. So company B has the most fuel-efficient car, and its miles per gallon is around 45.5 miles per gallon. Last of these, letter D, using the same graph, it says company B's graph is larger than company A's. What does that mean? What does that mean? Why is company B's graph larger than company A's graph? Take a couple seconds, think about it, pause the video, write down an answer. When you're ready to continue, hit play, and we'll go through it together. And we're back. And actually, I fixed a couple typos in case you didn't notice. So Why is Company B's graph bigger? Simply because the data is more spread out. It's not that they have more data. I mean, for all we know, we could be talking about 10 cars here, 10, 10, 10, 10, 10, 10, 10. So they're each talking about maybe 40 cars, but Company B's cars have a bigger range of fuel efficiency. Remember range, the biggest minus the smallest? Well, the biggest minus the smallest for Company B is bigger than the biggest minus the smallest here. So Company B has a bigger range. They're more spread out. They're not all jam-packed together. And that's what it means. All right. Lastly is the question from the textbook, and we're done. So it says here from page 882, the graph below shows the amount of rainfall for 2 towns in Texas over a year. All right. So this is the number of inches of rainfall they receive. In the example above, for how many months was the precipitation in Dallas more than 2.6 inches? Now, again, if this is over a year, this bar represents 12 months of information. This is 12 months of information. So, how many months was the precipitation in Dallas more than 2.6 inches? Pause the video, think about it, do it on your own. When you're ready to continue, hit play, and we'll go through it together. All right, and hopefully you said the answer of 6 months. This from here to here is 6 months of data because it's half of it. This is the median. That's the middle. So from the middle to the upper would be 6 months of data, half of it. This other bit here, that's 6 months. Also, if you think about it this way, 3 months, 3 months, 3 months, 3 months. So each section of the graph is 25% of the data. It's 3 months worth. So those 3 months had between 1.9 and 2.3 inches of rain. Those 3 months had that much rain. Those 3 months had that much rain. And those 3 months had that much rain. So it was a total of 6 months that had more than 2.6 inches of rain. And lastly, I would like you to list the information you learned about a box and whisker plot. So in that summary box, make a list of everything you learned about box and whisker plots today. Go ahead, pause the video, do that on your own. When you're ready to continue, hit play, and we'll go through it together. Now, I'm not sure what kind of information you wrote down, but I put down a couple different pieces. So, for example, each section of the graph is 25% of the data. So in that box and whisker graph, each whisker is 25%, and each section in the box is 25%. I have that you find a median 3 times. So when you're actually making the box and whisker plot, you find the median, the upper median, which is the upper quartile, the lower median, the lower quartile. And I have here that the graph is made of 5 pieces of information. That'd be the upper extreme, lower extreme, upper quartile, lower quartile, and median. All right. And homework comes from page 889, numbers 1 and 2, and numbers 7 through 10. This has been lesson 13.8. Thank you for watching. Bye-bye.